Now for this question, what we've got, put the ground here, and we have a pigeon. So there's my pigeon there, and it is, I should at least give it a head, I suppose. Right, so it's carrying a small little rock here, and its height above the ground is 50 meters, and it takes 3.5. Oh, and it's traveling along with a velocity here, u. It's not actually explicit in the question here. I'm assuming they're meaning the pigeons traveling horizontally because of what they ask for immediately, which is that if it takes 3.5 seconds for the rock to hit the ground, then it's not, the rock isn't traveling horizontally. So I think they're wanting you to contrast this with the pigeon who's flying horizontally, so the rock gets launched out of the pigeon. Anyways, we'll show that we can't have a situation where the rock is traveling horizontally and it hits the ground in 3.5 seconds. So if the rock is traveling horizontally, so it's going across like that and it's dropped to the ground, down it goes like that, we can think of this as just a UVATS problem, UVATS problem, and we're only looking in the y direction vertically here. So the u vertically, not to be confused with that u, is 0 because it only has a horizontal speed, and the horizontal speed we don't know. We're claiming, I suppose you want to say it's a claim here that it's going horizontally. The v is unknown. The a is minus 9.8 or minus g. The t is 3.5 seconds, and the s is minus 50, dropped by 50 here, and the t is 3.5. Now let's see if these numbers are valid. So which equation does not have v in it? So we have v equals u plus at, v squared equals u squared plus 2as. So it's going to be the last one, s equals ut plus a half at squared. So that means minus 50, dropped 50, is 0, and then minus a half a, which is g, and then t squared. Okay, so that's cancelled the minuses on both sides. A half of g is 9.8, so that's 4.9, and 3.5 squared, that's 7 over 2 squared, so that's 49 over 4, I believe. Okay, so I think we can see quite clearly that the left and the right can't possibly be the same. You could hit this in on the calculator to double check, but I know this is not going to be 50. I mean, there's no way it could be 50. What have we got here? We've got a number which is, I think, could be pretty close to 50 actually. Like this is roughly 50 over 4, 12 times 5. You know, actually let's see what it is. We'll probably need a calculator for the next part anyway, so we might as well calculate this. Okay, so 3.5 squared, that's the 49 over 4, times 4.9, so that is 60.025. So you can see that the claim is false. It couldn't possibly be traveling horizontally because we don't get consistent numbers here. So it must be the case that this gets launched at an angle when it exits from the bird, from the pigeon. So we don't know what that angle is, so we'll call it theta. and this is u, and we have our two usual components. This is the component which is in contact with theta, so that's the cos side, so that's u cos theta, and this one here is u sine theta. Now we'll have to look at some horizontal and vertical here. So let's have a look at the vertical. So in this case here, the u is not 0, it's u sine theta vertically. The v we don't know, the a is minus g, the t we do know, 3.5, the s we do know is minus 50, and if we were to look horizontally, that's just the distance, speed, time triangle, because there's no acceleration horizontally. So the distance, we don't know. The speed is u cos theta. So distance, speed, and the time is also 3.5. So actually in this picture here, I could work out the distance if I like. Right, so let's form some equations here. Let's see what we can say here. So again, we want to try and avoid the one that has the v in it because we don't know the v. So we can say s equals u t plus a half a, so that's a half g, t squared, so that's 3.5 squared. Now, do we have enough information here to get anything? We don't quite have enough info from this, so we can't solve this for u, we can't solve this for theta. And if I look here, all I can learn is that the distance it travels horizontally, which is the range, that's equal to 3.5 times u cos theta here. So since they're looking for the maximum height, we need to know what happens when the v is 0. So let's see what equation we can make in that situation, and perhaps we have enough info here. What I'm hoping is that the equation to figure out what the maximum height is, so that's the s vertically, will contain u sine theta, because if I was looking for u sine theta, I could do that here. I think it should. So if we're looking now at the maximum height, u is u sine theta still, the v is 0, the a is still minus g, the t we don't know the time to the maximum height, and the s we don't know, and that's actually what we want. So I can say here s equals u t. No, that's no good because we don't know the t, but we do know the v this time, so let's go with v squared. So v squared equals u squared plus 2 a s. Now let's see, that is all good. So I'm looking for the s here. I can rearrange this as u squared sine squared theta over 2g. Now this is nice because you can think about it like this. This is u sine theta over 2g, and the u sine theta is squared. And you can actually know the u sine theta from that equation, because you can get minus 5 plus a half g 3.5 squared. That's equal to 3.5 u sine theta by just taking this piece from the right to the left. So if I divide by 3.5, I get u sine theta equals a half g 3.5 squared minus 50 all over 3.5, and I can put that in here for u sine theta. So let's get out the calculator and calculate that. So that's a half times G times 3.5 squared minus 50 divided by 3.5. So that's 2.86, and I'm going to square that and then divided by 2G. So that S comes in at 0.4186. So the total height from the ground is going to be 50 plus this 0.4186, because we're taking the pigeon's level as the x-axis, and the question says round to the nearest tenth of a meter, so that's 51.4 of a meter.